A bit shift register is a register where the bits can be shifted either right or left. The register can be only part of a word or multiple words in length. The bits in the register can be used to indicate the presence or absence of a part as it moves through multiple stations, or it can be used to represent the kind of part or some particular action that needs to be taken on that part when it gets to a particular station. This simulation is an example of the use of a bit shift register. Near the beginning of the conveyor, a sensor detects that a bottle is broken and places a 1 in the shift register to keep track of the broken bottle. The 1 would be shifted into B3:6/0. Further down the conveyor is a solenoid and gate which will reject the broken bottle when the 1 in the bit shift register reaches that point. The solenoid will be activated when there is a 1 in the bit position B3:7/3. The bit shift instructions are found on the File Shift/Sequencer tab of the instruction toolbar. The bit shift left or BSL instruction will load a bit into the first bit of the register and shift the bits to the left until they reach the end of the register, and then the bit is shifted out to an unload bit. The bit that is loaded into the register is defined by the user, and the unload bit is in the control word. The bit shift right instruction, or BSR, shifts bits in and then to the right until they are shifted out into the unload bit. The operands are the same for both the BSL and BSR instructions. File is the address of the bit shift register. Control is a unique address in the R file for status information. Bit address is the address of the source bit that is going to be shifted into the register. Length is the number of bits in the bit shift register. The control word contains 4 important status bits. The enable bit is true whenever the instruction is true. The done bit is true after each time the bits in the register are shifted 1 position. The error bit is set when the instruction detects an error, such as in entering a negative number in the length operand. The unload bit is the location into which the last bit in the file is shifted into. This ladder logic program with a BSL instruction is designed so that when the limit switch is closed, the status of the sensor I:1/1 is shifted into the first position of the shift register, and all other bits are shifted 1 position to the left. A bit that shifts out of bit 15 of a word will shift into bit 0 of the next word. Unused bits in a word cannot be used for any other purpose. In the simulation, whenever switch LS1 is closed, the status of the switch at I:1/1 is shifted into the first position of the bit shift register, B3:10/0. Each time LS1 is closed, the bits shift 1 position to the left. On the next closure of the switch, the 1 will shift out of bit 15 of B3:10 and into bit 0 of B3:11. We can also look at the status bits. When the switch is closed and held closed, you can see the EN and DN bits are a 1. On the next closure of the switch, the 1 in the bit shift register will shift out into the unload bit. This example shows a simple application of a BSR instruction. When the limit switch closes, the status of the sensor at I:3/5 will be shifted into the last bit position of the shift register B3:51/7, and each position in the register will be shifted one position to the right. Bits shifted out of B3:51/0 will be shifted into B3:50/15. When the simulation starts, there is already data in the bit shift register. Every time the switch closes, the data is shifted one place to the right. Next, we will enter a single 1 into the bit shift register and observe it shift to the right through the register.